Okay, this now brings us to our next video. Our next video, give me just a second, I'm just going to make sure you've got all of it visual here. All right, this is our section 1.5 video. And so you don't have to write any of this down if you don't want to. I'm just going to use it to show you something here in just a second. And what we're going to be talking about in this particular section is we're going to be talking about a reading problem, an application problem, as it relates to the section we just finished, which was called quadratic equations. Now, before I get to the problem that I want to talk about, we have talked about some reading problems in here before. In section 1.2, we did two kinds of reading problems. We did perimeter problems, and then we did investment problems. Well, we're about to revisit some application or some reading problems. Well, why didn't I just cover this then when I covered that section with you? Why didn't I cover these reading problems at the same time? I'll answer that question in just a few minutes. But before I do that, I just want to make sure first that you understand what one word here is, and it's this. In this particular section, I think you have like 4 problems for homework in section 1.5, and it deals with rectangles, but it deals with area of a rectangle. Now, earlier in section 1.2, we looked at the perimeter of a rectangle. We're talking about something here altogether different now, and we're talking about the area of a rectangle. So let's suppose I had a rectangle that looked like this, and let's suppose each one of these squares, each one of these distances right here was a foot. So this is 1 foot, this is 1 foot, this is 1 foot. So you got 1, 2, 3, 4, 5, 6, 7, 8. So that distance right there is 8 feet long. All right, this is 1, this is 2, this is 3. So the distance from here to here is 3 feet tall. So you've got a rectangle that's 8 feet long and 3 feet high or tall or wide, if you will. All right, before I talk about area, let me talk about another word that we've already talked about, and that's the word perimeter. The perimeter of an object is the total distance around that object. So if I ask you what is the perimeter of this rectangle, it would be like taking a tape measure and putting it right here and going here, and then here, and then here, and then here, and seeing how long that is. So the perimeter is how far it is around it. So it would be 1 foot if you're walking it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So it's 22 steps all the way around it. Or you could have just said 8 plus 3 plus 8 plus 3, which is 22 feet. So the perimeter of this rectangle is 22 feet. That's how far it is all the way around it. Now, what I want to talk about is not perimeter. I want to talk about area. Now, area has to do with the amount of space inside that object, not the distance around it. So the perimeter is 22 feet. Now, what is the area? The area is the space that's in it. Now, area is always measured. Area is not measured in feet or inches or yards. It's measured in square feet, square inches, and square yards. For instance, if you go look at carpet and you're pricing carpet, it doesn't say that the carpet is $4.32 a foot. It says it's $4.32. Actually, it's written foot squared. A foot squared in square feet is the same thing. So if it says it's $4.28 for a square foot, that means a square that is 1 foot by 1 foot. 1 foot, it's like a box. 1 foot by 1 foot is a square foot. So if I ask you how many square feet is in here, you just count how many squares. This is 1, 2, 3, 4, 5, 6, 7, 8. 8 squares. But 1, 2, 3, 4, 5, 6, 7, 8. Another 8 squares. And then another 1, 2, 3, 4, 5, 6, 7, 8. So you've got 8 squares, 8 squares, 8 squares. So if you add those together, what do we have? 24 square feet is what's in here. Now, what's a quicker way to do that other than counting all of these squares? To get the area of any rectangle, you just simply multiply the length times the width. Now, that's not what you do with perimeter. Perimeter, you have to add all 4 sides. But the area of a rectangle, you just simply multiply the length times the width. So, right here, let's see. So the area would be 8 times 3, which is 24 square feet. But the perimeter is 22 feet. That's the total distance around it. So in these problems, what we're going to be looking for is we're going to be looking for the length and the width. I'll talk more about that in just a second. But before we even begin, write down this formula right here. So you need to know this formula to work these problems. Length times width equal area. Or you could say area is equal to length times width. Same thing. All right, so how do we use this problem to work the 3 or 4 reading problems that you've got in this section? All right. Okay, write this example down. Here's the problem. The length of a rectangle is 3 inches longer than twice the width. The length of a rectangle is 3 inches longer than twice the width. Continue the problem. If the area of the rectangle is 14 square inches, 14 square inches, find the length and width. All right. First of all, if you will notice, I'm going to state a couple of obvious facts in this problem. First, notice that this problem is dealing with area. Area of a rectangle. Now, what's the formula for the area of a rectangle? Length times width equal area. All right, how do we work this problem now? All right, got to go back to section 1.2. I told you this in solving a reading problem. I said there's 4 things I look for in every reading problem. Do you remember what they are? Number 1 was a heading. What do I mean by heading? That's where we say let X be whatever. So that's the first thing I'm looking for. Second thing I'm looking for is your equation. The third thing I'm looking for is where you solve it. And then the fourth thing I'm looking for is your concluding statement. All right, so what about our heading? So let's talk about that for a second. If you'll remember in section 1.2, I told you that whenever you're doing your heading, you're going to let X be something. And I made 3 statements. I will make them again now. I told you that whenever you're making your heading, if you're asked one question, you always let X be that one question. But then I went on and made another comment. I said, if you are asked more than one question, you let X be the one it talks the least about, the one it says nothing about. And then I went on and said, if you don't know more about one than you do the other, you're free to choose. You can pick whichever one you want. All right, so how do we declare our variable in this problem? Well, the first question, simple question you need to ask yourself is this. First of all, what am I even looking for in this problem? Well, in this problem, we are looking for the length and the width. Find the length and the width. That's two questions. When two questions is asked, how do we decide which one to pick? Remember, you can't say let x be the length and let x be the width. You can't let x be both of these. Now, you could if you knew they were equal. If it said the length and the width were exactly the same, then I'd say let x be the length, let x be the width. But I can't do that here because I'm not told that. As a matter of fact, I'm told just the opposite. All right, so you're asked two questions. When you're asked two questions, how do you pick which one to let x be? So I'm going to either let x be the length or I'm going to let x be the width. Which one? Well, let's read the problem again and see if we know more about one than we do the other. Remember we said in this case, if you do know more about one than you do the other, you let x be the one you know nothing about. So let's see. It says the length is 3 inches longer than twice the width. The length is 3 inches longer than twice the width. Now, does it say anything about the width? No. Nothing. So that's what I'm going to do. Since it mentions nothing about it, I'm going to let x be the width. Now, that's not going to be my own heading, the only heading. You may not remember me saying this, so let me remind you. When we covered section 1.2, I told you that if you have one question, you will only have one heading. If you have two questions, you'll have two headings. If you have three questions, you will have three headings. Well, in this problem, we are looking for two things, the length and the width. So we're going to have two headings. Well, I've already got my first heading. Let x be the width. Why did I let x be the width? Because it didn't say anything about the width. Why can I not let x be the length now? Because it did not say that they're equal to each other. So, what did it say about the length? It said the length is 3 inches longer. Stop right there. 3 inches longer means add 3 to something. Longer than twice the width. Now the width is x. So twice the width would be 2x. So the length then would be 2x plus 3. Now there's my two headings. Now do length times width equal area. What is length? 2x plus 3. What is the width? It's x. Length 2x plus 3. The width is x. Equals, and then the area we were told is 14 square inches. Now that square is on the inches. It's not on the 14. So this is just 14 right here. Length times width equal area. All right, so now I want to multiply these two things together. Now I know that looks weird, but if you put that x in front, it's the same thing as if you leave it behind it. But you're multiplying this one term times both of these. This is what we call the distributive property. So if I distribute this, this would be x times 2x is 2x squared. X times 3 is 3x equals 14. Now I mentioned to you this a while ago, and I can now explain it. I told you, why didn't we cover these problems? I asked the question, why didn't we cover these problems back when we covered the perimeter problems? The reason is this. If you look at this problem, this is a quadratic equation. How do I know that? Because of the x squared and the equal sign. So that's one of the things that makes this different. The reason I didn't cover this at that time when we did 1.2 is because at that moment in time we had not covered quadratic equations. So you say, Mr. Reiner, are you telling me then that all area problems end up being quadratic equations? That's exactly what I'm saying. All of these will. All right, how do we solve a quadratic equation? Now, let me go on and say this before I go any further. Be sure you listen to this. There's 4 methods that we use. 2 of them work sometimes. The other 2 work all the time. If I give you an area problem, and I will on test, and you have an area problem in the homework, which you do, I will make sure that every area problem I give you is factorable. So you can solve it by factoring. I'll make sure that I hand pick those. So in the middle of a reading problem, I don't want you to have to use the quadratic formula. All right, so this right here, according to what I just told you, then should be factorable. How do we solve a quadratic equation by factoring? Step 1, you have to bring everything to one side and set it equal to 0. So I'm going to subtract that 14 across. Now, I need to factor this. All right, give me just a second. Let me see if I can get all of this on here. Hold up, just give me just a minute before I tell you to pause the video. Let's see. Okay, here's what I want you to do. This is right here is where we were at. I want you to pause the video now. What you see over here is scratch work. So pause the video now and copy all of this and put the scratch work over on the side. So pause the video now. Okay, I'm assuming you paused the video and copied it. All right, so I want us to start right here, this line right here. All right, I told you that if you solve the quadratic equation, I'll make sure that it is factorable. That means that it has to be set to 0. Now, how do we factor this quadratic equation? By factoring. First, there's no GCF. That's out. Next, is it the easy case? No. This is the harder case one. This is the one where we have to use the Brew method. So I'm going to show you one more time how to do the Brew method. And then from this point on, I'll just use the Brew method. All right, so how did we do the Brew method? Remember what you have to do. Is you come over to the side. So what I'm about to do is factor this 2x squared plus 3x minus 14. How does the Brew method work? You take the number on the front and multiply it by the number that's on the end. So 2 times 14 is 28. Bring the x squared down and bring the 3x down. 2 times 14 is 28. Now what's in front of this is a 1. Now let's factor this. X squared breaks up x times x. Signs are different. Largest is plus. Signs are different, so one's a plus, one's a minus. The biggest number is going to go right here. Now, I need to fill in these 2 spots. How do I fill in these 2 spots? I need 2 numbers that multiply to give you 28, but subtract to give you 3. Multiply 28, subtract 3. 7 and 4. 7 times 4 is 28. If you subtract 7 and 4, you get 3. But the 7 has to be with the plus. Largest number is positive. So I've got a plus here and a minus here. Now this is where the Brew method starts. The B. B stands for bottom. Under the bottom of this 7 and this 4, under the bottom, put the very number that you multiplied by to begin with, which was 2. So you multiplied by 2, now you're going to divide by 2. So put that 2 under here and here. Now, R stands for reduce. 7 over 2 won't reduce. 4 over 2 reduces to 2. And then the last letter, U, stands for up. If you still have a number in the bottom, bring it up. And that's what I did there. Now, we're not finished. That's the factored part. So this scratch work is where this right here comes from. And also remember, you can FOIL it back out if you wanted to double check your answer. Now take and set both of these equal to 0 and solve. And when you do, you get 2 answers. Now, here's what makes this one different before we write out our conclusion. In a reading problem, you don't necessarily always keep all solutions. You have to remember we're about to write our concluding statement. Now, to write your concluding statement, I told you, before you write your concluding statement, always look back up at your heading. So let's look back at our heading. What was the heading? The heading said, let X be the width. Let X be how wide the rectangle is. Now, have we found X? Yes, we have. This one and this one. But it turns out that this one right here can't be possible, because what does X represent? It represents how wide something is. When you measure something, can it ever be negative? No. So this answer for the width, because it's negative, is not possible. So I can exclude that answer. And yes, it is typically true in rectangle problems, you typically will omit one of the two answers. But the other answer is 2. Now, can a width be 2? Yes. So, if X was the width, and it was, then the width is 2 inches. Now, how do I know it's inches? Because the area was 14 square inches. Now, we're not finished. Look back at your heading. X was the width, but we're looking for the length. Now, what's the length? 2 times X. Now, what did we just find X to be? 2. So, 2 times 2 is 4, and 4 plus 3 is 7 for the length. So, that's where this comes from. 2 times 2, which is 4. 4 plus 3, which is 7 inches. And by the way, if you check this, if you multiply the 2 inches times the 7 inches, you do get the 14 square inches. But remember, in any reading problem, I don't care if you get the right answer. In every reading problem, I'm looking for 4 things. If I don't see these 4 things, you get no credit. Don't care if the answer is right or not. I want a heading. I want your equation. I want where you solved it and got your answer. And then I want you to write a concluding statement. And don't forget to put units on your answers when you write your concluding statement. Okay, this concludes section 1.5, and it is the only video from section 1.5. It's a very short section, and you only have 3 or 4 problems for your homework in this set. Okay, so this concludes this section.